Hello viewers, this is Ronald taking you through today's tutorial, and in this video I'm going to share with you the solutions to A-level Subsidiary Math Paper 1 for UNEB 2019, and particularly we are going to concentrate on questions 9 and 10. So basically these are the very questions I left in the previous video, and I believe by now you have already tried them out and you are ready to get the solutions and mark yourself. So this was question 9 and question 10 was that. So those are the two questions I left with. Each question was carrying 15 marks. So now we are going to mark ourselves and check our progress. So let us start with question 9. Question 9 says, the table below shows the tax collection of a town council in millions of shillings for 6 consecutive months. So these are the months and this is the tax in million of shillings. So part A, they said construct the 3-month moving averages for the given data, and that is 6 months. So I think let us first try to answer part A. So part A is answered in a table form. You draw a table. First of all, you put the column for months, which is from January to June, and the column for tax, which are now called the points. These are the values, so you put here, this is the column for months, these are the columns for points, which is the tax. Now you are adding there July, because in part C they also ask for the tax collection for the month of July. So though here they stop at June, we shall add on a row for July because it was asked in this question of part C. Now, and because we don't know it, you are going to put there capital X, which is a letter, because we don't know it and it's not given. Now I want to see how to calculate these 3 monthly moving totals. Now for the 3 monthly moving totals, because of this word 3, it means that, I think, let me use a black pen. So for the 3 monthly moving totals, it means you are going to add 3. So you are going to first work on those 3. When you add this plus this plus this, we are going to come up with 67.6. Now why do we put it there? We put it at the middle. So this is the midpoint of these 3 values. Therefore we have to put the position matters. If you put this 67.6 here, that will not be okay. So you have to put it here at the midpoint to mean the 3 monthly moving totals. And when you divide by 3, because to get the average it has to be the number of items, so when you divide this by 3, you'll be able to come up with 22.53. so usually we round off to 2 decimal places. Now that is how they get this first one. Now the second one means you cancel this one, and now we go with this. So you are going to cancel this and you'll go with these 3 pairs, next 3 pairs. When you go add all these 3, we are going to come up with 72.3. Still it's put at the midpoint, which is that, and when you divide by 3, you'll come up with that. Now they do the same for the next one. To be now you're going to remove this one and add on the third one, which is that. So we're going the average of those. Let's first remove this so that we don't confuse ourselves. So we have cancelled this, we have cancelled this. Now we're going to get the average of that. So when I add all these ones up, I'm going to get 70.7, and I put it at the midpoint. And when I divide by 3, I'll be able to come up with this. So that is it. Next, now we are going to cancel. We have removed this, we have removed this, we have removed this. Now I'm going to get these 3. So when I add all these 3, I'm going to come up with 77.8, and I put it at the midpoint. Then I divide by 3 to come up with this value. So you have worked with this, worked with this, worked with this, and worked with this. Next is to add all these 3. Now those 3 will say this plus this will give you 51.6 plus x to get x plus 51.6, which is that. Then when I divide by 3, I'll come up with x plus 51.6 over 3. So basically that is our table for part A, and when you do it, you'll have got yourself the 6 marks. Now let us go to part B. Part B says plot the 3-month moving averages and the original data on the same axis. Note that word same axis, and give it 6 marks. Let us see how these 6 marks can be got. First of all, you must be having a graph paper. So that is our graph paper, and before anything you have to put the axis, put both the vertical and horizontal axis. Now after drawing that, you have to use a long ruler to draw those axes. After doing that, you are going to demarcate leaving intervals of 2 centimeters on the horizontal and also intervals of 2 centimeters on the vertical axis. Now that you have done that, we have to get a suitable scale and also so that we can fill in these demarcations. Now for the horizontal, we know that we shall count 1, 2, 3, 4, 5, 6, 7. Now we don't put there this 7, we only put what is given in the table. So 1, 2, 3, 4, 5, 6. When you count here 1, 2, 3, 4, 5, 6, so that means that we can now feed in those demarcations: January, February, March, April, May, and June. Then for the vertical, you have to look for a suitable scale, and when you get it, I'll use a suitable scale of 2 centimeters to represent 1 unit, so that I can feed in 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. And after that, you have to label. This is months and these are tax collection in millions of shillings. You also have to put the title of the graph. So the title is that a graph of tax collection of a town council for 6 consecutive months. Okay, now that you have done that, the next thing is to plot. We are going to start with, remember they told us to plot original data and the 3-month moving averages on the same axis. So we are going to, in order not to confuse them, we are going to first choose one. Let us choose to first plot the original data. Now the original data is this, and in this table it is this one under the column of points. Now that means that where there is January, you'll look for 21.5 here. So January you look for 21.5 and put it there, put a point. For February you are going to plot 24.3, March you are going to plot 21.8, and April will correspond to 26.2, May will correspond to 22.7, and June will correspond to 28.9. I think now let's do that. So this is January, February, March, April, May, and June correspond with the respective points here. So now after doing that, we are going to use a ruler to join those points, the consecutive points. So use the ruler to join from here to here, then from here to here, from here to here, sorry, from here to here, from here to here, and from here to here. Let's first do that. So I've finished joining those points, and I have to put a key because we are showing 2 datas on the same graph, so I have to distinguish them. So here I'll put my key that this full line denotes the original data. Now I'm done with the original data. I'm going to the plotting the moving averages. Remember I told you the position where I put the moving averages matters. Now this 22.53 will correspond to February, meaning where there is February you are going to put there 22.53, where there is March you are going to put there 24.1, where there is April you are going to put there 23.57, where there is May to correspond to 25.93, and this one you can't plot it, so you're going to only plot these 4. What you're going to do is elongate, as you're going to see. So let's first plot. So those are the points for February, March, April, and May, as you can see here. For June you can't plot it because you don't know this value. Now from there you're going to still use a ruler and join those points, but you're going to use dotted lines. So use dotted lines to distinguish this from the original data, and after that you have to put a key to show that this dotted line shows the moving averages. And you must have realized something, that here I've extrapolated this line, I've tried to elongate it so it exceeds this point of June. There is a reason why, and we are going to see it. So basically I've finished part B, where they wanted you to plot the moving averages and the original data. Now I'm going to part C, where they want us to use the graphs to estimate the town council's tax collection for the month of July. So that is why I've elongated it. Now this, I'll have to, before I get that collection for the month of July, I'll have to first look for the value of this moving average of June. So I'll have to come here and say, when I put a line for June up, and to meet this moving average, line for moving average, which are elongated, when it meets it, I'll take it horizontally this side to read off this value. And when I read off this value, it will be 28.2. What does that mean? It means that the whole of this, x plus 51.6 over 3, is equal to 28.2. Now let's see how that is used. But before we see that, let's first award marks for this slide, so that we can go to the next slide when we already know what you have got here. Now the whole of these values, for you to calculate these values correctly, you'll have got yourself those 3 marks. And also calculating these values correctly and in the correct positions, not that word, correct positions, you'll have got yourself those 3 marks. So those are the 6 marks for part A. Part B also had 6 marks. Let's see how they come about. Now this B1 is for both axes, well labeled and with a uniform scale. So both this axis and this axis, well labeled and the uniform scale, you'll be able to get that 1 mark. Then plotting the raw data. So for you to plot these points correctly for the original data, you get yourself this 1 mark. And this one is for joining using a ruler. So the lines have to be straight. You get yourself that 1 mark. And this one is for plotting the moving average points and in the correct positions. And this one is for joining using a straight line. And the last one is for estimation, for you to show this line, for you to estimate this next moving average here on your graph, and you get it. That's when you can get this M1. In other words, you have to see this line going up and this line going this side for you to get that M1. So 1, 2, 3, 4, 5, 6. So those are the 6 marks for part B. Now let's go to part C. Now from the graph, you already know that this x plus 51.6 over 3 is equal to 28.2. What we are going to do, we shall make x the subject, and when I make x the subject, I'll come up with 33. Now that I've got x, but remember that our tax was in million of shillings, therefore I'll say that the amount of tax will be equal to 33 multiplied by 1 million to give you 33 million shillings. Therefore that was the amount which was collected in the month of July. I think you remember in our table we put there x to denote the amount that was collected in July, and now we have got it, meaning this is the amount that was collected in the month of July. Now let us see how marks can be awarded. So this question part had 3 marks. So the first mark is for you to equate the 2, and this one is for you to simplify, and this one is for you to get the correct answer which was required. So now we shall go to question 10. Question 10 says the equation of a curve is y equal to 3 plus 2x minus x squared. Part A, determine Roman 1 the coordinates and nature of the turning points of the curve, and they give it 6 marks. So let us first begin with a Roman 1. First of all, the curve equation of the curve is y equal to 3 plus 2x minus 2. 2x. First thing to do is to differentiate. So dy dx will be equal to 2 minus 2x. Differentiate 3, you get 0. Differentiate 2x, you get 2. Differentiate x squared, you get 2x. So this is where this one is coming from. Then next, I have to remember that for turning points, the derivative must be equal to 0. So when I equate it to 0 and I make x the subject, x will be equal to 1. So I've got the x coordinate of the turning point. I also have to get the corresponding y coordinate. So when x is equal to 1, my y, I'll come and substitute 1 here, therefore I'll get y as 4. What does that mean? It means that the turning point is 1, 4. Next, I have to go for the nature of this turning point. Now the nature, I have to first get the second derivative. When I differentiate this, differentiate 0, 2, I get 0. Differentiate 2x, I'll get 2, but there's this minus, which is this negative. So I've got a negative value, meaning the second derivative is less than 0. When it is less than 0, it implies that the turning point is a maximum. So I've managed to get the coordinates and the nature. Therefore, I can now see how marks can be awarded. So the first mark, it was for you to differentiate, and the second mark was for you to get the value of x as 1, and the third mark was for you to get this y coordinate. Fourth mark was for you to get the coordinates of the turning point, and this one is for the second derivative, and this one is for you to state the nature of the turning point. So now we shall go to Roman 2 to say that find the y and x intercept of the curve. So the y-intercept is got when x is equal to 0. So when x is equal to 0, substitute for y, you come up with y equal to 3. And when y is 0, you'll be able to get the x-intercept. So when y is 0, you'll come up with 3 plus 2x minus x squared equal to 0. So now this is the quadratic equation, and therefore we shall use the bulldozer method. So in this case, our a is -1, b is +2, and c is +3. Therefore, when you substitute, you come up with x being equal to -2 plus or minus 4, everything divided by -2. So either x will be equal to when there is a negative, or x will be equal to when there is this, when this is a positive. Therefore, x will be equal to 3, or x will be equal to -1. Therefore, the y-intercept will be 0, 3, and the x-intercepts will be -1, 0, and 3, 0. So now we shall see how marks can be awarded. So this B1 will be for you to get the y value when x is equal to 0, and this M1 is for you to substitute in the bulldozer, and B1 is for both x equal to 1, 3, and x equal to -3. This A1 is for, now this A1 is for the intercepts, both y and x intercepts. So now we shall go to part B, Roman 1. Part B, Roman 1 says sketch the curve, that is 2 marks, and then find the area enclosed by the curve and the x-axis, which is 3 marks. So we have already got the turning point and the intercepts. Therefore, the curve will be in this form with a maximum point in y-intercept and x-intercepts. But remember to label your curve and the label also the axis. So that was Roman 1. Now Roman 2, they want you to get the area enclosed by this curve and the x-axis. So what we shall do, the x-intercepts will act as our limits. So we are going to integrate this curve using these as the limits. That we shall integrate from -1 to 3 of this curve, which is 3 plus 2x minus x squared with respect to x. When I integrate 3, I'll come up with 3x. When I integrate 2x, I'll come up with x squared. And when I integrate x squared, I'll come up with x cubed over 3. And when I substitute the limits, start with the upper limit where there is x put there 3, I'll come up with this, and then minus the lower limit where there is x, I'll put there -1 to come up with this bracket. Now when I simplify further, this will give me this will give me that, and in the end I'll come up with 32 over 3, and therefore the required area will be 32 over 3 square units above the x-axis. So now let's see how marking can be done. So B2, this one is for this sketching. So correct intercepts must be labeled, turning point must also be labeled, and the axis must be labeled. Then this one is for integration. For you to integrate this to come up with this, you get that M1. Integrate substitution, you also get a mark, and output, which is the area, you get the third mark. So I've gone through the corrections to question 9 and 10. I'm going to leave you with question 11 and 12 for you to try out, and this question will be carrying 15 marks. So that brings us the end of this lesson, and the solutions for the assignment left will be available in the next video. Otherwise, thank you for watching, and please subscribe to my channel if you have not yet subscribed, and also share it to as many students as possible so that we all excel as a family.